Hello.
Hey
Good
there.
morning. Good afternoon. So thanks guys for joining again. We had a great session so far. I mean, hopefully this one will be as interesting as the others. So I mean, the folks that have joined sessions so far were really great speakers. Unfortunately for ours, we had the last minute or rather last evening cancellation, so there'll be only 3 of us. And I will be, in that respect, playing here 2 roles, moderator as well as speaker, but as well as there are only 3 of us, you can think of it as almost like a joke. There is a guy entering a bar. So there'll be 3 people entering a bar. And as normally when you enter, no anybody else. Till then I will just say myself, I'm Veselin. I am a CTO and co-founder of Waylay, the company which is behind, or rather, one of the biggest sponsors of this event. We are into low-code, no-code. And before we continue, I would just like to pass the ball to you, Karl.
Sure. Hi, I'm Karl Wehden. I'm Program Director for Quantum Cloud Services at IBM. I'm building out the quantum network for serverless execution of quantum workloads. Good to meet you.
How about you, Alex?
Yeah, of course. So I'm Alex. I work at Theodo and I'm a cloud architect there. We're a company that helps other companies launch or transform digital products, whether that's like a brand new startup trying to get an MVP out, or a more established company trying to spice up their tech scene, go from 5-6 year old legacy system to a brand new serverless system. Not quite as interesting as your work, Karl, but I enjoy it.
So to manage expectation, I'm not going to talk so much about quantum computing. Having said that, I'm curious. Maybe there are some adjacent points. So again, Karl, if you have something interesting to share, be more than happy to hear about these things. But I just wanted, before we start, maybe a little bit of an intro. So in a way, what serverless has to do with the low-code, no-code? When I was thinking about that, there is always, like, you can go to Wikipedia and start Googling or whatever, what is actually serverless about? And without getting too much into theoretical discussions, is it a cloud function? No, is it a microservice or not? In a way, we think about low-code, no-code. The problem is that subject matter experts or experts in general can contribute without needing to code too much. One thing that is kind of sad sometimes is that you see kids thinking about the code is required to do their job. And then you have in schools like a lot of coding exercises, because otherwise people will not be able to do anything useful in the future. Or you have ideas like, no, you just have to know your own thing, and then software is enabled to that. And in that respect, low code is kind of a promise that we can suddenly empower everybody to enjoy building automation, whatever use cases, without the need to code too much. But there is still a little bit of a snippets of code, and eventually that code has to run somewhere. And this is there where this connection is between, if you like, serverless as a new snippet paradigm versus building applications. So I just would like to get your opinion on is there, if you like, a connection, or is that the only way to think about low-code, no-code in context of serverless, or is it something else maybe that might actually change the complete paradigm yet again? So how about that for a start?
I guess to start, working with mostly serverless architectures, I find we do use a lot of low-code, no-code solutions. I liked the part you said where it allows like subject matter experts to contribute to the system you're building. So I find code stays the most manageable when you tie it to the problem space really well. It uses the same language, it follows the same structure as the actual problem. So being able to sit in front of a more GUI tool and build, say, a workflow with an actual expert in that area, it's naturally going to be a lot closer to their actual problem space than if I listen to them, take notes and go away and write it out in code. Being able to have them see something a bit more simplistic than what's actually happening, but like a visual explanation of what's happening and being able to almost guide me along the way is super helpful. I also find like the serverless paradigm matches up really well with this when we're looking for no-code providers, because low-code or no-code providers that use serverless often follow a lot of the tenets that we like of serverless anyway. So like it's often pay per use instead of a bulk package. Often I don't have to worry about if we get massive scale, will that platform scale with it? Usually these sort of guarantees are built in because it uses the same technology underneath the hood that we're using when we can't use low code, no code.
Thanks, How about you, Karl?
Yeah, no, I think I'd certainly echo some of what Alex says around the ability to focus in this context. The less boilerplate that you write, the more focused you are on the actual performance of the service or module that you're writing as a part of that story, and the more the capacity to scale and the capacity to deploy is built into the flow that you're using at any point. Again, the less distracted by the capabilities and more focused on the actual features that you're building you get, and that's really certainly something that's very supportable in a consistent manner as part of that piece. The tendency towards low-code descriptions is not just something that's prevalent in pure development scenarios, but also in scientific workloads. You'll see a lot of folks picking up and driving low-code use of markup and the like to describe scientific process, experiments, and the like. So it's not just developers. It's a whole raft of different people who have the need to focus tightly on a specific domain area as part of that. So it's an interesting process.
Touched about interesting point where I see a lot of success of serverless. I'm not saying this is the only place. It's really in the machine learning pipelines. And it might be just because this is a kind of a flow sort of problem that is easy to solve by kind of chaining functions, if you like, or chaining the steps from one to the other, where the input of the next one is the output of the previous process. So is there a limit how much we can ask from the cloud functional serverless in that respect of the automation? And I just would like to get your opinion on that, guys.
Yeah, sure. This is actually a topic that's kind of near and dear to me when it comes down to it. So one of the things that I think when we were looking at putting some effort into improving the overall serverless experience was the underlying management of state. I spent a long time working on a platform called Akka, which is a distributed framework as part of this. And very recently, some ex-colleagues of mine have released Akka Serverless, which is the idea of being able to support the state transitions in functions by essentially making state a consistently available flow point in this context. Why do we want to do that? Because consistently having to rehydrate or recapture state to perform work is a lot of extra boilerplate. A, B, it takes time, and you want to be able to pass not just the inputs in and out of a function, but also state flow as well as part of that. And we see a lot of different interpretations of that through different modes. Certainly, that's one of them. We use Ray a ton as well in this case, specifically because the quantum workloads often look very similar to a machine learning pipeline in that case. And quantum is stateless, so you have to manage state outside of that context today. It's an interesting story, and I think it's innovations like improving state management in these cases, and then exposing them clearly in a low code, no code way, or through simple function adornment to be able to support those pieces is going to be a big differential as we continue along the serverless journey.
Yeah, I observe from my experience, because we are actually in domain of providing orchestration on top of the serverless, that if the functions are stateless, let's assume that for the moment, then there is overall state management required to basically have like a control signaling framework, which enables to control when things get executed and to have a shared context in between these stateless functions. So I've seen many people trying to do something like a database DynamoDB thing. So before we continue on the problem of the stateless orchestration, Alex, how from your day-to-day job, these things look in practice, not in the quantum computing, but maybe, I don't say down to earth some other problems. So how you deal actually with this sort of a persistency problem, when you need somehow to orchestrate and synchronize stateless functions?
Yeah, so we do rely on stuff like Dynamo quite a lot to be able to read and write between lambdas quite quickly. I don't do too much machine learning in my day job. There's a bit of data analytics, but being able to, on the data analytics side, say pipe events through something like Kinesis into an S3 data store and then have S3 trigger lambdas for any sort of processing and be able to use tools like, say, AWS Glue to do any transformations along the way. I think what serverless brings to enable me to be able to do this stuff without being an expert is simplification. I'm not going to go and learn a bunch of hardcore machine learning at university because that wasn't something that I leaned in towards when I was going through that stage. But now I can leverage other people's understanding in these managed services to be able to do basic analytics that most companies need. They don't need hardcore machine learning. And then when you implement stuff, so say you dump all your events into an S3, new services come out all the time. So like we were using QuickSight as like a BI tool for a recent client so that they could create graphs very easily for all the analytics that pipe through. And now, reInvent last year, they announced, I think it's called QuickSight Q, which does NLP over the top. So you can write a question and it will create the graph for you based off your data. So for me, it's a simplification. I don't need to be an expert to be able to produce usable data. Whereas previously you would hire people that was their job. All they did was machine learning. You needed to be experts. And those people still exist. They're the ones making these awesome tools that I can then leverage. But it brings it to more people.
One thing that I'm observing is, okay, I mean, obviously the serverless comes with the microservices and API exposed capabilities. Either they come from the same cloud provider or even from third party. I mean, I'm interested in the weather or I'm interested in some other functionality. But again, it's something that I also have observed is that as we start, if you like stitching these API endpoints, you mentioned S3 bucket as one of the ways to do that, because obviously that your context, shared context, is a bucket or event trigger through which you're then evoking other things. So, and I noticed that working very well in terms of the pipeline. So, but isn't then the problem very similar to like function versus object-oriented modeling goal, that you have a lot of small living snippets of code somewhere, and eventually over time, I don't say things are getting out of the sync. It's very hard to figure out what the heck is going on around, or you don't see that as a problem in your day-to-day work.
So it definitely can become a problem. I've been on projects where either we've come on and that's the problem is pre-existed, or even it can be quite easy to fall into that trap. I think the key way we get around it is being able to really define your boundaries well. So I normally lean on something called domain-driven design, but basically you try and set up your boundaries to match the boundaries of the business. Like I said earlier, I usually find most of the complexity comes from the problem space. And if a business has been around for 50 years, they've probably tried a few different configurations, how they want to structure their teams to solve that problem. Reflecting that in your code allows you to usually group together behavior at the right size. So if you did just have like, you hear this term nano service, that each lambda is a nano service. If you just had a bunch of lambdas calling each other or spitting out events to Event Bridge, your individual lambdas might be super simple, but it would be so hard to get the full big picture of what's going on. But if you can group things around a few core areas, so like a client I had recently was a online conference platform similar to this one. And so a few core areas you might break it down to is like chat is pretty much a completely independent thing. You can build chat by itself, use a micro front end or something to embed that into the platform. So you can build that as like a nice little boundary. And then it's not too hard to go into that, usually say its own AWS account even, go into that account, see the resources here, see how they interact together. And within these boundaries, something like step functions, or I believe the Waylay tool is quite similar, allows you to orchestrate these together. And then if something fails, you can even look at a nice visual graph and see where it's failed. But if you get these boundaries wrong, if they're too big, then everything is there's too much going on when you go down that level, and it becomes quite hard to see where the issues are. If you make them too small, then the connection between these boundaries, that you end up getting the same problem. So it does take a bit of training, a bit of reading, following some somewhat strict methodologies to be able to get these boundaries right. But usually the business will have solved these boundaries, and just you reflect them in the code.
How about you, Karl? What is your experience with that?
So I couldn't agree more. I think domain-driven design is an excellent way to drive that. And what I've generally also thought is an important sub-factor to this is the focus on data ownership within the context of a service, and the definition of how you would share things. I'm a huge proponent of, the concept of event sourcing as a focal point for this sort of architecture. And you can get the domain correct, you can get data ownership correct, but one of the things that we see consistently people falling down with is the idea of what an event is in that sort of model. So an event is, not just something that's happened, but something that cannot unhappen, that couldn't unhappen. Immutable. Basically is the point. Yeah. Immutable. Immutability as a definition is an interesting concept to describe in terms of a business context, and can often result in a lot of fun as part of that. But if you get all those things right, you have a win for sure in terms of how that works, and you have less dependence on what I would call the gravity well that surrounds the database in these applications. Also, you don't take the cost of storing and retrieving every time you want to drive those pieces. You can just use an event log to push those scenarios, and that's something that's consistently applicable in these models as well, and really important to, I think, producing some solid systems in these flows. And honestly, eventing and serverless make a lot of sense together in the sense that you've got an opportunity to share similar actions with multiple services without tight coupling as a function of how that works. So 100% behind that. Go ahead. Sorry.
No, I was just wondering now, speaking about functions and something that is reusable, obviously there is a small, if you like, single responsibility dilemma, if you like. If you make it very thin, then there are a lot of things happening around. Like you also, Alex mentioned, would like to maybe add a little bit of, I don't say logic into that, but something which is maybe a little bit bigger. So obviously there is some sort of a trade-off between, how you write functions, and moreover, I'm most interested in the company you are in, how you basically train new people that are just come out of school of understanding these dependencies or these trade-offs. Is everybody just throwing functions there and then stitching together, or is it like something should be aware of or not? Amazon also has a layer technology which enables you to kind of share some of commonalities across different functions. So maybe just a couple of points. I'm just curious how you see this problem of the cloud functions, and in terms of what they do actually.
So with the training point, I think that's really important in how do you succeed at serverless, is making sure you have a good training mechanism set up. So I think it was almost something that Karl said, that event-driven systems work really well with serverless. And most people, when they try serverless for the first time, they read some articles, they read this and they're like, okay, event-driven or even event-sourced is the way to go. But they've never done event-driven or event-sourced before. So now they're learning not just a new architectural way of doing things, but also they're using serverless for the first time. It's a lot going on. So I've been quite lucky when I joined the serverless side of Theodo, that there was a guy called Ben Ellaby, who's a serverless hero, who'd been doing it for a couple of years to train me. And something we really focus on is when we work for clients, training their internal teams, not just delivering something and leaving. Because I think serverless sometimes gets a bad rap for how complicated it actually is. Because you join a company that's, say, doing something more traditional, like a Spring Boot backend or a Django backend, there's going to be an engineering team that's been building that for a couple of years. They know their stuff. And when you have questions, you know who to ask for help. You're not just reading articles and trying things out. So building that expertise within the team is really important. But if you don't have that expertise, how do you get there? I find similar to Django or Spring Boot helps you out by being using frameworks like the serverless framework with a few plugins that have rules that try and guide you in the right direction, and using, say, the AWS well-architected framework to constantly review what you're building to make sure you're going the right way. The knowledge is out there. It's just not as common. People didn't do event-driven as much as they try to do when they move to serverless, and so it's very easy to fall into the trap of, say, the distributed monolith.
Indeed. So is that the problem, object versus functional programming, or let's say server-side computing, or a monolith where you have a lump stack where everything is in there, things do not escape and come back? Is it also something that you observe as, what I see often when we do the training on our system, which is serverless by design, people struggle. And you wonder whether this is me or them. Is it something that Dijkstra said once famously, it's very hard to unlearn things. And then the question is whether it's intuitive to think about architecture and applications as event source driven applications, or we are actually more like a sequential sort of animals where we want to actually look at things in a straight line. So since we talk about, these things, Karl, what is your opinion on that? Just I'm curious.
So, in all things, right, we need to make the hard, simple thing rather than the easy, complex thing, right? And in many ways, we've been using event source technologies for decades now. A database redo log is the best example of an event sourced architecture imaginable. We don't expose that complexity necessarily to every user who uses SQL, but we certainly have a situation where the overall features are available as part of that. And I think it's our job overall as the builders of applications and tools to better understand what that framework looks like and what we can expose that is comfortable within the context of the user to meet the user where they are today rather than where we'd like them to be, and deal with these issues like contention and consistency and all the other sub-factors that are driving everyone in this direction without necessarily reinforcing the need to consume and read every single paper that you can get your hands on about event sourcing. Because let's face it, no one really likes that. We shouldn't have to do that to people. So the simple hard thing, especially in your context here, Veselin, is exactly where I think we need to go with this when it comes down to it.
Yeah, on our side, Alex, thanks for mentioning. So we are in a way trying to solve problems similar to what AWS step functions are doing in a slightly different way. Reason being is that step functions are very good. That's actually BPM engine, finite state machine, which is really great in respect to customer use case driven things, workflows, and so forth. We are into domain of IoT and OT where things are a little bit more real-time sort of thing. So there is events coming. It has to be like a flow engine, but again, you need to understand what's going on. So I'd like to have some sort of finite state machine as well. So before we continue, so what is your experience with some sort of orchestration tools? Do you use them? And when you use them, actually? I would like to hear.
We use step functions quite a lot at our work. So particularly, as I said before, within bounded context, what I really like about them is when something does go wrong, it's very clear where exactly it went wrong. You can see the flow of information or data, the steps they've gone through. And so I quite like that. Step function, at least, is you see your red square. You can click on, okay, I know that lambda's gone wrong, and go look at the logs. I can see, okay, the data that was passed to it from the previous step wasn't quite right. It makes debugging quite simple. The other thing I quite like is you do get that visual graph. So like I said, businesses have often solved this problem theoretically before. They have an idea. Turning that to code and innovating on that is our job, but they have an initial idea we can base it off. So if I can go back and show them this workflow graph, which a lot of them are quite used to, and say, does this kind of look like the workflow you're expecting? You can often get some really good challenges from the subject matter experts. They're like, oh, no, you probably change these around. They can actually help simplify it because they have that domain knowledge. And we're now speaking in like a shared language. We both understand the graph, maybe in different ways, but we can talk about the solution that we're trying to build.
And do you use this debugging at the design time or at runtime? Just curious, at which moment in time you are relying on the tool itself to basically create a use case? Is it more of one or the other, or?
So we designed the step function to solve a particular problem, but there's not much debugging going in the design stage. It is kind of like when something goes wrong, I find they make it easier to figure out what went wrong. Right. So in runtime, out in the wild, when something unexpected happens that you've not thought about, it's easier to track through where it's gone wrong. Where if you do like
sort of explainability problem rather than
exactly. That's a really good way of putting it.
Yeah, because that's what final state machines are about, understanding the state transitions and why you went from A to B, basically. Yeah. And how about the error handling? I mean, how do you find that within just curious. You have these retries or something. I mean, does it typically happen in the production that you have to handle these error paths separately, or you map them as states? I'm just curious how you deal with that in real life.
Yeah, so because we do them within these bounded contexts, they're usually not that complicated. So small, like retries are often enough. Sometimes just having different error states too. It can vary a little bit depending on what the problem is, but they're never particularly long state machines. A few steps, like a client I'm currently working with, every time they publish an article, they've just got a few steps they need to do to go have it marketed, to go refresh the static website that they've built. It's fairly simple. If one of them goes wrong, you don't really need to do anything to clean it up. You just need to notify. I don't know if this is an official term, but chat ops, we get pinged in Slack saying that the step function failed, so we know to go have a look at it, so we're aware of the problem. But a simple problem like that doesn't need too much logic around it, other than retrying it a couple times and then putting it on a dead letter queue if it continues to fail.
Okay, thanks. How about you, Karl? What's your experience with the orchestrators?
Yeah, I think in many cases we're usually working on a very different type of workload. So the orchestrators that I'm using are generally focused on aggregating as much available compute as possible to solve computationally intense problems.
Do you mind to explain a little bit to audience and myself what kind of loads are we talking about?
So workloads we're talking about are typically what we're calling hybrid quantum classical, and classical is everything that's not quantum, meaning a normal compute package as part of that. One of the things that some of the early applications of quantum that are becoming popular at this point are things like molecular modeling and simulation, something called variational quantum eigensolvers, or VQEs, that are very good for solving closed system optimization problems. As part of that, think things like routing, portfolio optimization, and the like. In this case, and these are variational algorithms. So what happens there is you select a solver, and you select a proposed answer or an ansatz, and you vary your response to triangulate on an answer in this context, which is a computationally intensive process that may or may not require a ton of classical compute associated with a quantum system. So being able to pick up and deliver, a lot of compute quickly without having to worry about allocation or structure is quite important. And so this has been interesting for us.
You mean that you're then basically distributing computation itself to
Absolutely.
Delegate? Okay, so it's that sort of a cloud function, which are then, and then how do you merge results? Is it something that then happens? I mean, I'm just curious how these things work.
So it depends on where the target result is being merged. So there's many cases where you may use different techniques that describe qubit state, or basically the ideal output state of an evaluation, either virtually by combining different pieces of hardware or different technologies, doing something called entanglement forging as part of that story. Think of it as like MapReduce for quantum computing, basically. As part of that, and we would do that within the context of a specific classical computation set. So we've been playing around with things like lithops, for example, to be able to do some pretty serious runs. We were playing around with this recently and did a 10,000 core test on lithops for some simple matrix multiplication as an example. We were able to pull together in a couple seconds somewhere around 300 teraflops of compute to be able to perform some of these operations for about $20 in terms of a total read through.
Wow.
In this case. So in many situations, problems that you couldn't solve with raw non-serverless orchestration, just because the complexity of setting them up would have been too much, or totally within reach, especially in this case. So I think you're going to see more and more of what I would call the serverless supercomputer playing a role in some of these key problem spaces
I see,
as a function of how it's working. Those orchestrated flow points, because they're generally starting in the quantum space, are ephemeral and generally aren't something that you have a state problem with overall. Yeah. But in the future, I think being able to hand off as part of a pipeline is going to be pretty important. And we see a lot of different approaches and ways to deal with that, for sure.
So in that respect, probably it's easier to shard, as all these independent cloud functions, so to speak, are immutable in a way. They do not necessarily need to share data. Mm-hmm. If I'm not, so that makes it a little bit easier. But I'm curious then, Alex, other places where you might have a fan out of functions that they are grabbing the same resource, and how would then deal with that sort of a problem? Just curious to see your point on that. Obviously, if you have thousands of things getting into the same resource, you might have a contention problem. So.
Yeah, I guess with the sort of applications I've been lucky to build with serverless, it's usually reading a lot from the same source, but not writing a lot to the same source, or if they are writing on different rows. So you don't have these issues of things like conflicting with each other, or like having out-of-date reads where you read something that's changed and then you make decisions based off that. Hasn't been too much of a problem with the particular applications I've built. I know there's a few different strategies out there for how to handle it when it does happen, but I thankfully enough haven't had to face them too often. I do know I had a client that was building an event source system where S3 was their event source, and you don't have guarantees about the read and write, or you didn't used to, you do now, about read after write, that if you read after something's written, that it's definitely there and available. So you'd have this where you try and get a resource but didn't actually quite exist yet. Thankfully, things improved though, and so that sort of problem doesn't exist anymore. You have stronger guarantees. The other one is like eventual consistency. Sometimes, if you're doing a global architecture, just because you've written something to Dynamo doesn't mean in another region it's available yet. But usually, I find that that's not cause problems. But like our applications, because they are designed to be event-driven, can handle this eventual consistency. It's all right if like I said, a current client is a news publisher. So right, if a comment on a blog post, a comment on an article exists in the UK for a couple of minutes before it exists in the US, that's not a problem with the sort of applications we've been building.
Yeah. Eventual consistency is an interesting context, right? Because in many cases, it's a function of practicality. I'm not sure if it's still that way, but for example, SNS is eventually consistent. People don't treat it like that. People don't use it like that, but the reality is, as far as I remember, it's still just a functionally and eventually consistent tool set in that case, but people use it as if it's completely consistent.
Yeah, for most cases, you can just ignore it. Like, be aware of it, know that that's how it works. If there's an interesting bug, you need to understand how it actually works. But a lot of people get in their head a bit too much about eventual consistency and trying to engineer things.
I often joke, if people assume something is consistent, which is eventually consistent, you're building eventually inconsistent system. Now, the question is whether people care about that or not. I mean, it depends really on the use case. And, in case of the IoT, as we are in, if there have thousands of events, do actually even people notice that? I mean, there is really, all depends on the use case and even the application of, and often people, I don't say don't care, they just even don't notice these sort of nuances. Now, maybe just as a way we try to solve that, the problem that sometimes we see is that event comes. Let me give you one simple example. Imagine you have water meters. You have thousands of these, 100,000 of these. And you would like to make a rule, a threshold crossing on a value. Now imagine that value is different for different customers. So obviously then that information about the value threshold, it's not in the event itself. You have to somehow correlate it with the event which comes from a database or another source. So how you then do that? basically what we ended up doing was to create some sort of abstraction of some sort of a digital twin, where at the moment that someone is creating a use case for a given water meter, we grab that information and throw that in automation context, such that you do not need to query a database at the moment you're creating the rule. By the rule itself, we know what we need to pick up from other systems in order to make that always consistent rule. Otherwise, you might be fetching a threshold while everybody else is trying to read or write something, and then nothing really happens, or rather something can strangely happen. Now, obviously, then it brings me to another story of event-driven systems, because what happens if someone changed the threshold? Because then somehow you have to figure out the other flows and trying to understand who has subscribed to these change events in order to update the rule on the fly. So this is basically a lot of these things we've done that I don't say people do not appreciate, people don't understand. To build eventually consistent system, you really have to have this context aware and state machine somewhere within the automation context, which is not necessarily in the database, but might be as well distributed. We ended up doing something probably similar to what you, Karl, mentioned earlier on. I just checked this article, where we basically have a distributed context, which gets, at the moment events is coming, getting kind of, again, rebuilt so that we know where we are at a given state or phase of the state transition, so to speak. But it's actually a pretty complicated problem.
Yeah, the complicated part is making it simple in many ways, right? State and phase transition is not something that you'd want to expose in a consumer level API for sure. And in many ways, I think you could see a lot of people working to manage those pieces in the most simple way as possible. I have some friends here in Seattle who work on a framework called Cadence, which you're probably familiar with as well. That's well designed to do that sort of thing. And I remember talking to Maxim over there a while ago, and my baseline with Akka, all that's exposed. You're defining the state machines you're operating on in that context, and it took a long time for me to realize that, in many cases, you want to keep that out of the consumer API and make sure that it's something that you push down. So, Veselin, the problems that you're solving, I think, are critical.
Indeed. And then it's the last thing you want is to expose that to the end user, because again, some things people assume these things happening, but again, this is the challenge, and I think this is something that I would relate back to the service community. If people ignore these problems, or rather imagine things being infinite because functions infinitely scale, there are many other aspects of the microservices that need to be orchestrated, and this is also a part of the things why we have this conversation. The other thing that I noticed, and I don't know whether this is problem in your space, it's related to security. And here I don't mean security in terms of very simple definition like who can touch something, like authorization, authentication. It's more like, in our case, an object being owned by someone, and then the cloud function. What is that? Who is owning that one? And you put that orchestration on top of that. Who can do what? So it's an interesting problem. And I don't know whether you guys have been faced with this and how you think about it. Again, give you an example. I write a function, I can give it to you. You can run it. But then the object, Karl owns that object. And then finally, I create automation on top of that, which is given by someone else to operate on Karl's object with Alex function. So how these things actually happen in real life. I'm just wondering whether you guys have seen these problems and what you think about it.
Yeah, ownership is an interesting area. I think Karl kind of mentioned this earlier when we were talking about domain-driven design. So the way we like to do it is anything that within a domain, they should own the data. If they need to know about it, you duplicate it in that bounded context, and it can only read from the resources within that same bounded context. And so it's about how do you keep things in sync between bound contexts. If they need to update, we'll normally do that through events. Those bound contexts will listen to events and update their own, say, Dynamo tables. Means you're duplicating, but storage is getting cheaper and cheaper. It means that you can only ever read from things that you explicitly should have ownership over. You're not reading from, it's not two different systems, one reading from the other's table and maybe having access to information it shouldn't. The other thing is people are often far too permissive with the permissions they give their serverless functions. One of the first things I always check with a new client is how many stars there are under resource access. Doing your best and having like actual tools that check that you're not doing that, I think is very important, making sure each function has its own policy. That policy only has the absolute minimum that it needs to achieve its goal.
Yeah, very nice. Yeah, I would just add, especially in the context when we're sharing events between complex systems in these cases, our tendency lately is to move towards more of a coarse-grained response. So if someone is requesting a model scoring event, for example, you don't just return the answer, you return the version of the model and a reference to the source data that you used to do this. And if someone so chooses, they can import that into their bounded context and continue to use it in that case. And I've generally shy away from sharing any databases as a result. In fact, as long as you're willing to be comfortably accept the nature of the request through the API, you should be kind of done with where you are with that story, and let the other system worry about how they'd like to store it, how long they want to store it from that perspective. So I would go even a little farther into the extreme data ownership in that case, for sure, because the idea of crossing over from a function and object ownership scenario just sounds like you're building virtually blocking systems at that point when it comes down to it.
You mentioned interesting stuff about versioning. So I wonder how, in practice, people do that. I mean, we obviously have our own versioning of the cloud functions and other things. So the question is, indeed, as you have all these multiple functions and models, is there a commonality among, let's say, professions, how to deal with that? I mean, is there something like application versioning even possible? Or we are taking a snapshot in time of functions and data models to understand what is actually happening, who has developed a particular feature. So again, interesting subject. I don't know how much time we have for that, but again, I would just like to get your opinion on that.
Yeah, I'll react really quickly and then hand it over to Alex, but I think this is exactly why you start to define a clear definition of what an immutable event is, right, as part of this. So you should be consuming the events that are the output of these scenarios and provide coarse-grained context when it's appropriate to what you're doing as part of the event. But for the most part, you don't want to be in the business of snapshotting every subservice that contains, an ephemeral data store that's not bounded to the nature of the event you're working with. Otherwise, it's just a complexity nightmare, in my view. But go ahead, Alex.
Yeah, no, to be honest, I completely agree. I think your events being your source of truth, version your events so that you can change the structure if you really need to. But yeah, events are things that have happened, and so you can use them to figure out what the current state of anything should be. Any other way, it just gets quite complicated. You have a bunch of scripts that transfer one current state to the new current state. How do you roll back then as new things are added? It just becomes a bit of a mess if you.
What could go wrong?
Found
really?
Another way. Yeah, I've not found another reliable, nice way. That's not to say it's simple, but like reliable will work. Maybe hard, but simple.
Just a question, Alex. Now, imagine you have a Lambda function. There is a bug in there, and it's a part already of AWS type function in yet another place. So how basically you deal with that?
So ideally, if it's a new bug, you can roll back to the previous function very quickly. But if your lambdas are pumping out events, then you can because you versioned your events, look at what events have happened with that version and try and remedy them with like an upscaler or something that transforms them into something that's more valid. But at the very least, you've then got, okay, 5 things happened with this Lambda that I know I need to go fix. So I know the scope of my problem. But you want to always be able to roll back quickly and not having to roll forward when you find a problem. So versioning your Lambdas and stuff is very useful.
All right, thank you, guys. To start with the analogy that one guy more entered the bar. So it's Karl probably going to kick us out. That's probably your role now.
Just quickly, just wanted to say that we're just going to a quick break, and we've got the unicorns coming, the UNICON unicorns coming up in the investor chat. So stick around; it'll be about 25-minute break. So join the booths and have some fun. Thanks very much, guys.
Before, I would like to thank you guys